Hi everyone. Today we're going to talk about composition of functions using tables and graphs. So in the past we've discussed inverses, and we haven't discussed them really in depth, but we have discussed how you're supposed to switch x and y, and we've discussed how to find the inverses in a table, on a graph, and with an equation. And so today we're going to give ourselves a little bit more knowledge so that we can further our knowledge of inverses. So the topic today, composition of functions. Composition means to put together. And so if we're putting together functions, then that means that we're going to be dealing with more than one function while we compose them. So typically, you end up with a composition of functions looking like this. And the way that you pronounce this is f of g of x. You will also see this, and sometimes people call it fog, but what this means is f of g of x. So this little thing right here, you can think of it as meaning of, because that's your composition of functions that's happening. So when you compose these functions, f of g of x, this means that you substitute g of x, whatever your function g of x values are, you substitute them into f of x. So you take them and you put them right here, and then you evaluate your function f at that new number. So let's look at the examples. I'm going to leave that on the screen. So the example says f of x equals 2x minus 5, and g of x equals 4x plus 1. I need to find f of g of 3. So it will be easiest if I rewrite f of g of 3 like this. So f of g of 3. So we're going to work from the inside out. So from the inside, I have g of 3. G of 3. That's kind of like g of x. So what that means is that your x value is 3 in the g function. So I'm going to go ahead and find g of 3 here, meaning I'm going to replace all my x's with 3's in my g function. So 4 times 3 plus 1. 4 times 3 is 12, and 12 plus 1 is 13. So now I'm going to evaluate f of g of 3, and g of 3 was 13. You see how that works? So we have the inside, g of 3, that's 13. And so now I'm going to evaluate f of 13. So I have f of 13 equals, here's the f function, f of 13 equals 2 times 13 minus 5. 2 times 13 minus 5. Well, 2 times 13 is 26, and 26 minus 5 is 21. So f of g of 3 is the same thing as f of 13, which has a value of 21. So we worked from the inside. We put the 3 in the g function. We got 13. And then we put the 13 in the f function. So that's what composition of functions looks like. You work from the inside out, and then you're able to find your composition value. So occasionally you'll be asked to evaluate the composition of functions using tables or mapping diagrams and graphs, which we'll show on the last page of our notes. Now we have some information about the domain, which isn't really going to make much sense to you until you do some of these problems. So I'd like to show you exactly how to do these problems. In problem number 1, we're asked to find f of g of negative 3. And if I rewrite that, that's f of g of negative 3. So remember, you work from the inside out. G of negative 3 is negative 3 for x in the g function. So I'm going to go look for the g function. I have 2 tables. One of them is g of x. The other one is f of x. So I'm going to go find -3 for my x value in the g function. That's this table. So here's -3 for x. G of -3 is 2. So I'm going to find f of 2 because g of -3 is 2. Now I move to my f function. I want to find f of 2, so I go find 2 for my x value. Here it is, and f of 2 is -1. So here's the path that we follow. We start out at -3 in the g function. We go find -3 for x in the g function. G of -3 is 2. I go take this, and I look for f of 2 in the f function. So this is kind of like the loop that we make. So let's try another one. Let's try f of g of -1. So I'm going to go find g of -1. -1 is my x. So here's the g function. X is -1 right here. G of -1 is -1. So now I'm finding f of -1. I'm going to go to the f function. X is -1 here. And f of -1 is 0. So the composition f of g of -1 is equal to 0. So why don't you pause your video and try number 3. Number 3. We're finding g of 0 first. So I'm going to go find 0 for x in the g function. G function, x is 0. G of 0 is 3. And f of 3 is 2. Okay. So I'm going to take my paper away. I want you to pause your video and try to fill in the composition of functions on number 4, 5, and 6. Pause your video. Okay. So on number 4, there we go. On number 4, you probably didn't have any issues with it. G of 4 is -3, and f of -3 is 4. So there's your answer for number 4. However, when you got to number 5, it probably started out just fine. If you go find x of 1 in the g function, so here's x of 1 in the g function, you get -5. But when you try to evaluate f of -5, well, there's no -5 here. The lowest number we have is -4. So that means that we don't have an answer. The answer does not exist with our data. And so to abbreviate that, you can use DNE for does not exist. Now you get more practice using DNE for does not exist on number 6 because you're asked to find g of -4. And if I go to the g table, where x is, there is no -4. -4 should be up here, but the lowest x value is -3. So since g of -4 does not exist, then we can't evaluate f of something that doesn't exist. So we say that the answer is does not exist. Now, up until this point, we've been kind of moving from the g function through the f function to get our answer. Now on number 7, it's a little different because on number 7, and I'll change my color here, on number 7, we're asked to find x. We're asked to find the x value such that f of g of that x value will equal 2. So you need to ask yourself, okay, if I'm going the opposite way, I need to start from the outside and go to the inside. I need f of something to be 2. So I'm going to go find 2 in the f of x column. So here is the f of x column. Here is the 2. F of what is 2? Well, f of 3 is 2. So that means that inside of these parentheses, we should have 3. Now, we need to go find what x is if g of x is 3. So I'm going to go look in the g of x column. I'm going to go find 3. Here it is. G of what is 3? Well, g of 0 is 3. So my x value to begin must be 0. So we kind of moved backwards. Here we moved from 2 to 3, and then we moved from 3 to 0. So that allowed us to find that the x value was 0. So you have 4 problems remaining. It's a mix of the first type of problem and the last problem, but notice now that you're finding g of f of something. So when you do that, g of f of -4, you need to go look for the f value, the function value where x is -4 in the f function. So here's the f function, here's -4, f of -4 is 3. So I'm finding g of 3. I'm going to go to my g function. Here is 3. G of 3 is 4. So make sure that you're going in the right order, starting from the inside to the outside. So if you're trying to find f of -4, you go to the f function, evaluate it, and then evaluate the g function at 3. So pause your video and try numbers 9, 10, and 11. So check your work for 9, 10, and 11. Number 9, g of f of 1 is equal to -1. Number 10, g of f of 4 does not exist because f of 4 is not defined. And number 11, if you need the x value that makes f of g of x equal to 0, well, f of -1 is equal to 0, and g of -1 is equal to -1. So -1 is your x value. So finally, we're moved to the back side of our notes. Notice that on the back side of our notes we have 2 graphs. One of them is for f of x, and one of them is for g of x. So whenever I evaluate some of my functions, sometimes it's easy as just finding the x value and going up to the graph and picking out the y value. For example, number 1, we have f of 0. If 0 is my x value in the f function, I go to the f function. I find 0, and then I go up or down to get to my graph. So I can't go up, my graph isn't there. I go down, my graph is right here. That y value is -1, 2, 3. Why don't you try this one? Check your answer. F of -5 on the f function, 1, 2, 3, 4, -5. I go up to a y value of 1. Let's move to number 3. We need to find g of -1. So in the g graph, I go to an x value of -1, and I go up to the point, 1, 2. G of -1 is 2. If I need to find g of 2, I go to the g graph, I go to an x value of 2, I go up to my graph. That's 1, 2, 3, 4. So up until now, these are not incredibly difficult, but now we start finding problems that ask us to compose these functions. So the first thing in f of g of 1 that I need to find is I need to find g of 1. So g of 1 is going to be in the g function. Where x is 1, I go up 1, 2, 3, 4, 5. So now my task is to find f of 5. Well, in the f function, if I go to 5, 1, 2, 3, 4, 5, I have to go up 1, 2, 3 to get on the graph. So I found g of 1 to be 5, and then I find f of 5 to be 3. So my answer is 3. Next problem. I need to find g of f of negative 2. So first I'm going to find g of negative 2. So I go to the g function, where x is negative 2, y is 1. Now I need to go find f of 1. So I go to the f function. F of 1 is negative 1, 2, 3. So negative 3 is my answer. I'll show you how to rewrite number 7, and then I want you to try it on your own. This is f of g of 3, or sorry, f of g of 0. So I want to find f of g of 0. I find g of 0 first, and then f of whatever g of 0 is. So pause your video and try numbers 7, 8, and 9. Okay. G of 0 is 4, and f of 4 is 1. G of negative 4 is 4, and f of 4 again is 1. G of 4 is negative 2, and f of negative 2 is negative 2. Numbers 10 and 11 are slightly different. 10 says, when does f of g of x equal 5? Well, that means that I need to go find where the function is 5. The f function is 5. So here's my f function. It's 1, 2, 3, 4, 5 right here. That's at an x value of 1, 2, 3, 4, 5, 6. So f of 6 is equal to 5. And now I need to figure out what x is if g of x is 6. So I'm going to go to my g function. G of x is 6 at 1, 2, 3, 4, 5, 6 right here, so across. And the x value is negative 1, 2, 3, 4, 5. So here we were looking for the x value. X equals negative 5. So I'm going to ask that you pause your video. I want you to try 11 through 16, and I'm going to give you the answers once you unpause your video. So number 11, is it possible for f of g of x to equal 7? No. Because here in the f function, 1, 2, 3, 4, 5, 6, 7, that's right here. That has an x value of 1, 2, 3, 4, 5, 6, 7. And then if I go here, there is no g of 7 because the graph stops right there. So no, that's not possible. Number 12 is negative 3. Number 13 is negative 3. Number 14 is negative 4. Number 15 does not exist because if I go find where f of x is 6, 1, 2, 3, 4, 5, 6, that's at this point right here, which is kind of like 6.5, an x value of 6.5. Well, if I go here, 1, 2, 3, 4, 5, 6.5, well, my highest y value here is 6, so that doesn't exist. There's no point up here. And then number 16, when does g of f of x equal negative 4? Well, the answer is x equals 6. So finally, I'm asked to find g of 1/2. Well, g of 1/2 would be about right here. So I go up 1, 2, 3, 4.5-ish. I'm asked to find where g of x equals 0. So g of x equals 0 is right here. That's at 1, 2, 3.5. And pause your video and try the last 3.